Hello, I'm Hilay Shah, and today I'll be talking about virtual memory in early microprocessors. So, some history about the virtual memory is that in 1940s and 1950s, the computer had very limited RAM, and the intensive computer programs had to use and what was available for the RAM. So the applications used to crash like very frequently. So a German physicist introduced the concept of virtual memory. Now virtual memory is very simple. It is sharing of the memory blocks between RAM and the hard disk storage, that is the HDD. So when the sharing occurs, there is empty slots available in the RAM, and uh, that empty slots can be used for parallel computing of the computer processes. So there are various methods by which virtual memory processes can be performed. One of them is called paging. So first we need to understand what the word page means. So page is basically a stack of words. So we know that a word contains 4 bytes of memory, and one page contains 4 kilobytes of memory. So a page is 1024 words combined together. Now, why do we use pages instead of words? It's because when we have 256 megabytes of RAM and 4 bytes of words, then the number required to address each and every word in the RAM is very large. So we combine 1000 words to make one page so that addressing a particular page becomes easier. A page table is a table which contains information regarding the virtual addresses and the physical addresses of memory. Now, virtual address is an address that is generated by a computer program, a computer process. Now, this virtual address is processed by the page table, and it converts it into a physical address. This physical address corresponds to a particular address in the RAM. It retrieves the information from the RAM and gives it back to the computer process, which uses that. Now, let us see the functioning of a page table. So, let us consider a 32-bit system. So, it will have a virtual address of 32 bits. Now the page offset is 12 bits. What is page offset? Page offset is something that is used to correspond to a particular word in a page. So a page would contain 1000 words. Now the computer needs to know which word to go to. So that number is defined by the page offset. And since there are 32 bits in the virtual address, the remaining 20 bits will be used to generate a virtual address by the computer process. Now since there is only 256 MB of RAM available in the computer, and each page contains 4 kilobytes of memory, the total number of addresses present in the RAM that would correspond to page number would be 2 raised to 16. Hence, a 16-bit number is required to correspond to a particular physical page number. Now, since the size of page offset is similar in both virtual pages and physical pages, the page offset needs no translation. However, the virtual page number needs a translation, as 20 bits is available in the virtual address and only 16 bits are available in the physical page number address. As we can also see in the diagram, the virtual address contains more number of bits than the physical address, and the page table also contains the information whether the physical whether the memory is present in the hard disk or not. So what happens if the memory is not present in the RAM and it is present in the hard disk? Now, as we know that the page table contains information that the memory is present in the disk, it would simply generate an interrupt that would shift the command of the OS to a page fault handler, a device called page fault handler. So what does this page fault handler do? The page fault handler is connected to both the page table and to both the memories, that is physical memory in the RAM and the hard disk memory. So first of all, it selects a particular memory in RAM that is not currently in use, and it transfers it to the hard disk memory, and the hard disk memory that is actually required by the computer process is transferred to the RAM in the place of our junk memory that was removed earlier. Now the main function, now one of the functions is also to update the page table, since page table keeps the tracks of all the processes that are occurring in the computer. So then, as it is connected to the page table, it also updates this information in the page table. And after updating the information, it goes back to the instruction that was currently generated, that was initially generated by the computer program. So now this instruction would go back to the memory management unit, which would again go back to the page handler, and the page handler would correspond to a physical memory address in the RAM, and the required memory would be present in the RAM because it has already been transferred by the page fault handler. Now the whole overview of the process is shown in this diagram. We can also see one TLB mentioned. So the function of TLB is to store the processes of the memories that have occurred recently. So if a memory has been transferred from the RAM to the hard disk recently, the latest information is stored in TLB. It is a kind of a buffer. So after the computer program generates a page number and offset, it goes to MMU. The MMU checks the TLB first because it is faster to extract information from TLB. If it is not a latest memory, then the MMU will go to the page table, and the page table will correspond to a particular physical memory address and extract memory from there. Now, in case the memory is not present in the RAM, then the MMU will generate an interrupt. That interrupt will shift the command to the device called OS page fault handler. Now the OS page fault handler has connections made to both page table and the disk. It will move some unused memory from the RAM to the disk and transfer the required memory from the disk to the RAM, and then it will update this information in the page table. Then it will again go back to the instruction that was initially generated by the logical address. Now as the MMU goes back to the page table, it will see that the required memory is available in the RAM itself. And so that is the overall picture in the case of paging. Now some other types of virtual memories include segmentation. In segmentation, the logic remains the same as paging. The difference is, in pages, the size of each page is the same, but in segmentation, the size of each segment is different. That is, different words are grouped together in every segment. Some computer systems also consist of both paging and segmentation availabilities in their hardwares. Now the pros of virtual memory are, when there are many parallel functions occurring, there is always some memory in the RAM that is not being used. So this virtual memory transfers that unused memory in the hard disk, so that there is some empty slot in the RAM which can facilitate more parallel computing. This also provides a sense of infinite memory, as the memory available in hard disk is much more than generated by the logical processing unit of the CPU. So there are always some empty slots in hard disk. So the parallel functions can also be performed despite low RAM availability. The main problem with expanding RAM is that it is very expensive, but using a virtual memory would would be helpful, as it would not lead to increase of the cost much. Now, the cons of virtual memory are that it takes a huge amount of time to perform one cycle of page fault generation. The main process of transferring the data between hard disk and the RAM takes about 80 million CPU clock cycles. So that is a huge amount of time. And when many parallel processes are running, multiple page fault generation cycles would be required. So the CPU and the computer would become very slow. So it is always better to have more memory available in your RAM, but if that is not the option, then virtual memory is also a very good and cheap replacement. So these are the references that I used to make this PPT, and thank you.